To improve the passenger Wi-Fi experience along the NEC, Amtrak is commissioning a trackside broadband wireless communications network along approximately 10 miles of the Northeast Corridor as a proof of concept. The pilot will be conducted between Raggan and Davis, just south of Wilmington, in Delaware. If successful, the project could be used as a future model to deploy the technology along more or all of the 500 miles of the NEC. The network will assess the viability of Amtrak and third-party owned infrastructure in the wayside to deliver fast train-to-ground connectivity with a significantly higher level of performance and quality than possible over commercial cellular networks, and with sufficient scalability to meet growing demand. To assist with network planning, Amtrak has created an interactive asset database using Google Earth Pro that contains layers of information including the rail line, station and milepost locations, existing communications infrastructure such as fiber and radio sites in or near the wayside, signals, transponders and other engineering infrastructure, and further physical assets such as bridges and buildings. In addition, the database has information about levels of Acela and Northeast regional ridership between each station, cellular network coverage, and current throughput achieved over the Amtrak Connect Wi-Fi service. Amtrak has chosen a proof-of-concept site that offers the best conditions to fully assess the wireless broadband technology required, including the physical and logistical challenges of designing, building, and operating a best-in-class trackside network. The 10-mile test site contains 3 locations with existing access to fiber in the wayside. Situated between Raggan at milepost 30 and Davis at milepost 39, these locations will provide the trackside network with connectivity to the Amtrak fiber backbone and onward to the internet, and are typically located in small, secure huts such as these shown here. Trains will communicate with small wireless base stations that are positioned on masts reaching up to 40 feet tall. Located in or near the wayside, these base stations will connect directly to the Amtrak fiber backbone, or use compact point-to-point microwave links to connect to the nearest fiber location. Preliminary investigation suggests that the proof-of-concept network will require at least 7 base stations along the NEC tracks. 3 of these base stations will be located at fiber sites, while the remainder will be positioned in the wayside up to 1 mile apart, and connected back to the fiber using up to 7 microwave links. The wayside base stations must provide complete radio coverage of the right-of-way with a signal of sufficient strength to maintain the highest possible data rate. This will be achieved using directional antennas facing up and down the tracks, and spacing between the base stations to allow a degree of signal overlap. Where necessary, third-party sites such as cellular towers close to the track will be leased to complete the wayside base station links back to the fiber. The actual infrastructure required will depend on a number of factors including physical topography, line of sight, and the presence of obstructions such as trees and buildings, and will be determined following physical on-site inspections and detailed RF analysis. In summary, the proposed proof of concept aims to validate the ability of a trackside network to deliver a minimum of 25 megabits a second to a train at speeds up to 160 miles per hour, with scalability over time to 100 megabits per second. Such a network will enable Amtrak to keep pace with Wi-Fi demand and offer world-class onboard connectivity for its customers in the future.